Hello, so in this chapter I'm going to show you how to solve applications of right triangles and finding their solutions. Now, when we talk about right triangles, remember that basically there are a few facts that we do happen to know, such as that A plus B plus C has to equal to 90 degrees. But since C is a right angle, then that means that A plus B has to equal to 90 degrees. The other thing of which that we will know about a right triangle is that the sum of the squares, a squared and b squared, has to equal to c squared. Now, though, what we want to do in addition is like be able to figure out, like what if we had one of the sides and an angle, or at least two bits of information, then in that case we can always use trigonometric functions. Because for instance, if I happen to know, let's say like B, and I know angle A, then that means that I can find the missing pieces like A and C, including angle B, because at that point I would know like what is angle A and C, so then by that logic we would know like what's the missing angle. So for example, I would say maybe tangent of A is equal to, okay, so remember in this hypothetical situation, we're saying that we know angle A and B, but we don't know what A is or C. So in this case, you would end up with tangent A of opposite over adjacent, so that would be A over B. Now in this case, like if you wanted to solve, let's say like for angle A, then you would know that all you need to do is just multiply by B on both sides. So A is equal to B times tangent of A. Okay, so that's like sort of an example of like how you would utilize the unknown information. Then once you have A, and now that you know B, you can either use the trigonometric functions or you can use Pythagorean theorem. I'm gonna kind of probably go between both, but we'll see. So in my first example, I'm gonna work in solving a right triangle. Now when we say that, we mean that we're looking for all of the missing bits of information. So for instance, if we draw a triangle, let's just do it like that. And we're going to say that this angle measure is 61 degrees and 20 minutes. And then we'll go ahead and say, for example, that the side is 13.8 centimeters. Now, for this, note that basically angle A is 61 degrees. That means that angle B is missing. So let's go ahead and just write this with this pen. So this is B, and remember that this is the right angle right there. So normally we would call that C. But the things that we don't know in this case are the side A that corresponds. So I'm just going to put like a side little a and then a side little c. That way we kind of have an idea like what's what. Okay, so now one thing that I will mention in terms of solving right triangles is that the notation technically doesn't matter. I mean, if you want to write that b is over here, then yeah, you can. But in any case, as long as there's consistency between like how you're solving these problems. So what we're going to do is a little bit of, extracting the information. So we have that we know what angle A is. We don't know A or C. And we do know the side B, which is adjacent. So let's do it like this. Let's go ahead and say that, for example, that we take tangent of 61 degrees and 20 minutes. We're going to say that that's equal to A over 13.8 So this is almost exactly just like the, the way that I kind of set up how do we solve for one of the unknown sides. Now, in this case, this means that A, if we multiply by 13.8 on both sides, you get A is 13.8 times tangent of 61 degrees and 20 minutes. Okay, well, let's go ahead and solve that then in this case. So we have 13.8 times tangent of 61 degrees and 20 minutes. Now, you're more than welcome to, go ahead and say like, well, isn't that just 61 plus 20 divided by 60? And you'd be correct in saying that, and then, let me just check my mode. Okay, yeah, you always got to check the mode. So tangent of that answer times 13.8. You just hit enter. So it appears that the missing side is 25.2 centimeters. Okay, so let's see if we do that the same exact way, but we're going to use the 61, and then we're going to put the angle, and then we'll put 20 minutes. And then we'll just hit enter. So 25.2. So we found that basically the missing side, and you can say that this is definitely not to scale, it's okay. The missing side, A, is 24.2 or 25.2. So we'll just put 25.2 centimeters. Okay, so that's side A. Now, in order to find side C, we can actually construct another method of finding the hypotenuse. So for instance, this is saying that we're going to use the adjacent and the hypotenuse. So that means that we should think of the trigonometric function that corresponds to adjacent and hypotenuse. Now that would be cosine. So cosine of 61 degrees and 20 minutes. And then that's going to be, let me see, yeah, so that's going to be 13.8 divided by C, and this is equal to 1. Now, if you get kind of clever, you can actually just flip this and say, well, that just means that C over 13.8 is equal to 1 over cosine of 61 degrees and 20 minutes. Now, it would be even more clever to say that this is equal to secant, but since the calculator doesn't have secant function, you might as well just leave it like that. So carefully saying that C is equal to 13.8 divided by cosine of the angle measure that we found, or that was given. And we're going to go ahead and say approximately. Now, you can actually verify this by using Pythagorean theorem also, and I feel like Pythagorean theorem is probably the way that we should have gone, but I just want to show you that like we can actually find it still by using the trig functions. And I'm going to actually go ahead and just take 20 and divide that by 60. That way I don't need to do anything. Okay, so we just hit enter. And 28.8. Okay, so that's going to be 28.8 centimeters. And that's for angle, or not angle, but side C. Now, let's go ahead and find angle B. Okay, so angle B can be found by taking B is equal to 90 degrees minus 61 degrees and 20 minutes. Now, some of you have asked, like, okay, how do I know how to do this? And my simple answer is just by saying, well, it's kind of like borrowing. You take 89 degrees, and then you have 60 minutes, and then that's minus 61 degrees and 20 minutes. So then that means that it's going to be 28 degrees and 40 minutes. So that means that angle B is 28 degrees and 40 minutes. Now, of course, we could have probably figured that out by doing the conversions. You know, like if you do 90 plus, not 90, well, yeah, 90 minus 61, but then you'd have to subtract the 20 over the 60 and see like how you're left with some change. So in that case, you just take the 28 away and let's see. Yeah, you multiply this by 60 and you get 40. So you get 40 minutes. Okay, now it looks like we found everything that we need. Now, I said earlier that we could have probably just did the 25.2 centimeters, 25.2 centimeters squared, and then plus 13.8 squared. We hit enter, and then we take the square root of that. And it gives us roughly the same exact thing, but it's off by a little bit, and that's just because of the rounding issue. So like, for example, if we would have used the original, like that one, and then we would have squared it, and then we would have plus the 13.8, and then square it, and then we take the square root of that. So now we have that, yeah, that of course this gave us like what we wanted in terms of one of the sides. But that's just one of those things where you have that, you know, obviously there is going to be some measure of error in this case. So, you know, if you read through the first section or first part of this section, it talks about significant digits. So notice that, like, you know, I knew that I was up one decimal place. So in this case, that's my significant digits for the sides. But you can still see that, yeah, that there was some measure of inaccuracy with regards to like when we verified using Pythagorean theorem. So it's just telling you that you just have to be careful with rounding sometimes and whatnot. Now, let's say that we work an example where two sides are known, but no angle measure is known at all. So let's say that, for example, that we have a triangle. Hopefully this does the right. Yes, okay, good. Now, let's say that one of these sides is 44.25 centimeters. And then let's say that one of the other sides is 55.87 centimeters. Now, in this case, one thing that we can do is mark, for example, the angles. So like this is going to be A and this is going to be B. So the thing that we don't know in this case is the hypotenuse in actuality. So we can probably figure this out. Well, we need to know the angle. So if we go ahead and we use the let's see. Yeah, let's go ahead and use that that if we know the two sides, we're going to use either tangent or cotangent, but it doesn't matter. So let's look at it like this. Take, let's write it in green. Okay, so take tangent of A is equal to 44.25 centimeters divided by 55.87. Now, here's where it's going to get complicated. You have to take the inverse on both sides. So A is equal to tangent inverse of 44.25 divided by 55.87. So in previous chapters, we looked at the inverse function, but only limited to the first quadrant. So we'll go ahead and do that. So 44.25, and we're probably going to have to do minutes in this case. So 44.25 divided by 55.87. And we're going to take tangent inverse of that. And we're going to hit enter. So that's going to be 38. Okay, so right. So that's going to be 38 degrees for sure. But let's go ahead and convert the degree part into minutes. So times 60. And we'll do 23 minutes. So A is approximately 38 degrees and 23 minutes. Now, if you want, we can go ahead and solve for angle B. So angle B, remember, B is equal to 90 degrees minus A, which in this case is 38 degrees and 23 minutes. Now, if you're okay with the borrowing, then, then it makes sense, like 89 degrees, 60 minutes minus 38 degrees, 23 minutes, which that equals to 51 and 37 degrees. 51 degrees and 37 minutes, sorry. So that gives us that. Okay, now, and we had A, didn't we? Yeah. Okay, now, in this case, we can actually solve for C however you want to at this point. We can either use the angles that we found, or we can just use Pythagorean theorem. It's probably going to be better to just use Pythagorean theorem, so we have C squared is equal to 44.25 squared plus 55.87 squared. Now, of course, you're going to have to take the square root of this top part. So I'm just going to put it like this, where we do the square root of 44.25 squared plus 55.87 squared, and then we're just going to hit enter. So that's going to be 71.27 centimeters. So we have 71.27 centimeters. So that's the side C. Now consider this, if we would have used the angle measure, if you would have used the angle measure to find the missing side, like for example, maybe like maybe like sine or something, or either cosine, depending, then in that case, you probably would have found that the angle measure, or I'm sorry, the side C would be a little bit off from 71.27. And that's just to say, that you just have to be careful when interpreting the angle, not the angle, that to maintain the accuracy, that you always want to use the given information as much as possible, and to avoid any rounding in any of the intermediate steps. So you ever see those questions where it says like don't round until you see your final result? That's kind of what that's saying. Okay, now the next thing of which that we look at in this section is what we call angle of depression. an angle of elevation. No, the angle of elevation and depression deals with an angle measure that's using the line of sight and the horizontal. So for example, if I draw like a set of two rays, let's do like that and like that, and we'll just call this X. So this is my horizon, okay, and then I have my angle of elevation. So let's just put that like that. Okay, so we call this um, the angle of elevation. So it's as simple as like saying that you're looking up at a flagpole or tree or building. The other thing of which that we can put, yeah, is that we'll just put like a little uh, letter right there. So that way you kind of have an idea like, oh, okay, there's a point of which that we're looking towards. So we also have that there's the angle of what we call depression. So let's do it like this. So let's say that we have a ray going in that direction, and then we have another ray going in this direction. We'll call this X, and then we'll call this Y down over here. Now, basically, it's the same exact thing. You have that this is your horizon, or your horizontal, and then you have that the angle of depression would be like that. So in this case, you have that this is the angle of depression. Now in this case, this is looking from the top, basically, in terms of like, like if you were at a top of a building or like that you were at some cliff. Now, the things of which that we can look at before we get to the next example is that there's sort of like a process of which that you solve these questions. So the easiest way to kind of show you that is by um, going to this process that a mathematician came up with, where he says that you have to have like these steps to problem solving. Technically, this is the steps to problem solving, but it's applicable to or um, it's applied to you solving trigonometric questions. So be sure that you do pause the video and that you do go through, the process that they say. So they say to draw a sketch, label it with the given information, label the quantity to be found with the variable, to use the sketch to write an equation relating the given quantities to the variable, and then solve the equation and check that your answer makes sense. This is more or less the four-step process that George Polya came up with. So like if you ever read the book How to Solve It, it's actually very, very interesting. I think that's the name, if I can recall. But basically, like, any math class, they're going to give you like a step process, and this is actually very relevant to that in terms of like solving application problems. Now, in my case, like when we look at the questions that follow, um, I actually already have kind of like a question in mind. So, and it has the picture already. So, in our case, like we're just gonna look at, yeah, we'll look at this example where basically I want to figure out the height of this flagpole. So we can see that the angle of elevation is 26 degrees, 40 minutes, and that the distance from the base or the distance, the horizon distance, the horizontal distance, is 123 feet from the base to where the line of sight was. So with that, we know that basically you have the angle, you have opposite, you have an adjacent. So tangent of 26 degrees and 40 minutes is equal to A over 123. Now what this means is that A symbolically has to be equal to 123 multiplied by tangent of 26 degrees and 40 minutes. Now, if you're kind of like saying, what was the whole point of this? Well, this is like in the case that it's a word problem, to be honest, and then plus, we already have our information kind of like labeled and all that kind of stuff. So in this case, like, we're just kind of like analyzing the diagram at this point and then just putting it all together. But uh, you can start from scratch if you want to do it like that, like where you have a word problem. So we take 123, we multiply this by tangent of 26 degrees. I'm going to go ahead and just put the minutes. In this case, it was 40, so that's 40 divided by 60. And we close it, and then we hit enter. So that's going to be that's 61.8 feet. So we see that we have 61.8 feet is the height of the pole. Now in this case, we're just using 3 significant digits, and that's because of the fact that you have 123. So in this case, we'll just use 61.8 feet. So in this next example, let's go ahead and look at solving another example where we have either angle of elevation or depression. So let's go ahead and look at this following question. So I'll just put it like this. So a company safety committee has recommended that a floodlight be mounted in a parking lot so as to eliminate the employee exit, as shown in the figure. So in this case, we have a figure already. Find the angle of depression of the light to the nearest minute. Now, in this sense, there's not really much to do, to be honest, because we have that. What you'll do is you'll just say that, okay, well, in that case, they're just looking for the angle of depression. So that'll be basically this angle right here. So, and notice that this is the same angle also. So what we can do here is just say that, okay, well, let's go ahead and let this value be theta, for instance, and we know that that's going to be theta too. So for here, we're just going to say, well, why don't we just take tangent of theta and then just say that we have 39.82 feet, we'll just leave those out, 51.74, and then from there, we know that we just have to take that theta is equal to tangent inverse of 39.82 divided by 51.74. Now from there, that's going to give us exactly what we want in terms of the theta. And they said to round to the nearest minute. So in that case, all that we have to do is just figure out what is theta using our calculator. Now, in this case, we have 39.82 divided by 51.74. Okay, so I went ahead and just did the computation. Okay, so tangent inverse of, we'll just do that answer and then hit enter. So that's going to be 37.58, but that's not what they wanted. I'm going to multiply this by 60 so that we can get the nearest minute. So it looks like it's 35 minutes. Okay, so that's going to be 38 degrees and 35 minutes. And then that's it. So the angle of depression is 38 degrees and 35 minutes. Now notice that in actuality, I suppose you could probably figure out like what the angle is over here, but you really don't need to. And then plus, look how the way that the light is beamed, like it's almost as if that there's another triangle. So let's not even think of it that far. So this question was just looking for that angle, which I used geometry and just said, okay, well, it's just alternating angles. So in that case, those two are equal. You might have questions like that in some cases, and it's always good to like go ahead and draw it out so that way you can see that that it's not that bad in terms of like figuring out like what the question is asking for, because I already kind of had an idea when it said like find the angle of depression. So in that case, like I knew that I was looking for one of these two, but it made more sense that you were looking for this one. Okay. Okay, so let me scroll back. Oops. Let me scroll back up so that way you can kind of get an idea of the process that I was talking about, like with respect to George Polya's step process in solving a word problem or problem solving techniques. So be sure that you read through this a couple times and that you kind of have an idea, because this is how you should be able to solve a question as it relates to, you know, exam questions or quizzes and things like that, or even like on the final. So just be sure that you do kind of like practice this, and you know, if you can get this down, then I would say that you can basically apply that to um, you know, like solving any kind of question as it relates to like even in like calculus um, or maybe like in physics perhaps, because like in this case like it's all really the same when you think about it in terms of like solving questions like that.